Uh, in the last class, we discussed about, we discussed one program in which two integers were added together and the sum of those integers was displayed on the screen. And then we discussed about the variables, the naming concept of variables. And we said that the names of variables is a type of identifiers. And each variable should be having a data type, because C holds data. Data can be any literal, any string, any numeral, etc. So that data is held by this C programming or C compiler in variables. So we have seen how variables should be named and what is a variable, and what are the different concepts involved in naming variables. Now, the types of data different data types that is available in C programming that we will be seeing in this class. So before that, let us remember our program that we used, that we discussed in the previous class, that is the adding two integers together. So in that case, we defined the two integers, integer 1 as well as integer 2 was defined as integer as int, that is the statements 8 and 9. If you look into the lines 8 and 9, there are these things. Okay, so we were discussing the simple C program that we discussed in the last class itself. Just a brief discussion, because just a recapping of the thing. So we defined three integers actually. Here we are defining three integers: integer 1, integer 2, as well as sum. This is the integer 1, that the value that is input by the programmer or the user is stored in this integer, and the second value that is input is stored in this integer 2, and then they are added together to form and that value is sent to sum. So then we printed the statement in the first integer, and then we scanned it using this particular statement, scanf. Scanf is another function which is available in stdio.h, so that within double quotes it is %d. We said that this is the format string specifier or the format control string, that is %d. So %d denotes it is an integer that is going to read. So that we have discussed. Then ampersand is integer 1. So this is how we read an integer into the program. So integer 1 gets the value that is input by the user. Then in these two lines we read the values, value for integer 2. Then here we sum, we add integer 1 as well as integer 2 together, and then that particular value, the sum of these two integers, these two variables, is assigned to another variable sum. Then finally we printf, the sum is %d /n sum. So then again we came across with this format specifier or format control string, that is %d. So it is at this position the value of the sum will be displayed when we print the value on the screen. That is how this %d symbol works, that we have discussed. Now in this case we have seen three different variables. One is integer 1, then integer 2, and integer sum. The sum, there are three variables, and before each of these variables there was a statement int, and this particular int means that this particular variable, this integer 1, that is a variable, and that variable will be holding values of type integer. Only integer values will be stored in integer 1. No floating point values, that is no points with the decimal values, no fractional values will be held by or will be stored by the integer 1. That is what this particular statement int, integer 1, means. So that is this int, it is a data type, that is represents integer type of data. Integer type, you know, that is 0, 1, 2, 3, etc., or 0, -1, -2, etc. That is the whole numbers, that is the integer type. So let's see the other types of data or other data types that is available in C. So actually, what is a data type? Data type refers to an extensive system used for declaring variables or functions of different types. So it is data types is actually a system which is used for declaring different types of variables, as in integer int integer 1. We are declaring the variable integer 1 as type int or as type integer. So that is the case with the declaring the variables and declaring the functions. In the case of our function, in the main function, we are starting it with the int main void. So there also the term int comes. So the return value or the return data type of the function main will be of type int. That is what it represents, int. Then the type of the variable determine how much space it occupies in storage and how the bit pattern stored is interpreted. So that is it. So the type of the variable, if I say that this particular variable is of type int, a specific value of memory, a specific amount of memory will be stored for or reserved for storing values that is to be assigned in that particular variable. So in the case of integer 1 is defined as int. So the size of int will be some specific amount of memory, and that much amount of memory will be stored for integer 1, and any value that I am assigning into integer 1, if that particular value fits into that particular amount of memory, then only that particular value can be stored. If that particular value, the value that I entered, exceeds the limit of the memory that is stored, then some junk characters will be stored. And we can see how these types of things are being displayed. That also we will see in today's class most probably. So then let's see what are the different types of data types. So the types of data or the data types in C can be classified as different types. There are different categories of data types, and the basic classifications are basic types. So the basic types are the arithmetic types and consists of two types, integer types and floating point types. That is the two different types in the basic types. Then the enumerated types. Enumerated types, they are again arithmetic types, and they are used to define variables that can only be assigned certain discrete integer values throughout the program. That is, if you define a specific variable as a type of enumerated type, then in that case you can only assign some specific values to that particular things. I mean that particular variable. No other variable, no other value that is available in that enumerated type can be assigned to that particular variable. That is the condition. That also we will see. Then the type void. When we defined the function main into function void, into main void was written. So it was written like this: int main, then within bracket void. Then I said that this void means nothing is passed into the function main. So no value or no character or no data is passed into this into the function main. And this void also represents that the same thing. The type specifier void indicates that no value is available, nothing is available. Void means nothing is available. So then there are the derived data types. The derived data types includes the pointer types, array types, structure types, union types, and function types. So that is that we will see later. These types of data, the array types, pointer types, etc., the structure, union, etc., that we will see later in the course of study. And currently what we are discussing is about the numeric types as well as the character and the string types only. No other things that we are currently discussing. And the basic data types consists of four different classifications, or four different types of data types are available in basic data types. That is the character, shortly denoted by char, char. Whenever in program, if you see it is the variable is defined as char, char, that means it can hold a character. A character can be any literal or any symbol that is available in our character set. Then integer. that is int, then floating point, float, and double precision floating point, double. So these are the four basic types of data types that is available. Then char, it is used to hold an ASCII characters like capital A, B, star, or any other 8-bit quantity, that is any character that is available in our character set, in the character set of C. Then int can hold integer quantities that do not contain a decimal point. So that is the integer quantities which doesn't contain a decimal point can be stored in a variable of type int. Then float. Float is used to store numbers with a fractional component or when larger numbers are involved. That is when larger numbers of the order of 10,000 or 20,000 or lakhs or crores is to be displayed, then int won't work. In that case, mostly we will be using float or a variant of float. So floating point values which has the decimal values. Suppose we want to store a value 1.5 in a particular variable. In that case, if it is an integer type cannot hold 1.5 because 0.5 is the decimal part. So it is not an integer. The 1.5 is not an integer. So we cannot hold or we cannot store that particular value 1.5 in a variable of type integer. But a floating point type variable, that is if that particular variable is defined as float, in that case it can be stored. Then double is same as float but has difference in the magnitude and the precision of the numbers they can hold. That is very large size values of the order of 10 raised to say 10 raised to 10 of the order of 10 raised to 10. If you want to hold that size value, that sort of values, then float may not be enough to hold that value. So for that purpose, you need to use double. Then void we have discussed. Enum is the enumerator type, that also we have discussed, and we will see it, the enum type that we will see later. So then there are some data type classifiers also, I mean data type qualifiers. The data type qualifier, or it is also known as the data type modifier, it is used to alter the meaning of the base type to make it suitable to various situations. So like the different qualifiers that is available are signed, unsigned, long, and short. So the basic data types were these four, that is character, char, int, float, and double. They were the four different types of basic data types. So along with this data type qualifiers, that is these modifiers, there are a variety of different types data types available. So it is signed, unsigned, long, short. So it can be signed integer, or it can be unsigned integer, long integer, or short integer, etc. So the long may also be applied to float and double. So this all these things, signed, unsigned, long, and short, all these four values, I mean four terms, can be assigned to integer type. So integer can be signed integer, unsigned integer, long integer, or short integer. The term long can be assigned to or applied to float and double. That is, it can be long float and long double. It can be long float as well as long double. But long float may be equivalent to double. The long float, or if we say that long float, then it is equivalent to double itself. So normally we don't go for long float, and if we want to do it, we want to go for long float, then it means it is double itself. Then the signed and unsigned can be used with the character type also. The signed char as well as unsigned char is also possible. This is possible with the help of ASCII characters, ASCII numbers. That is, each character, we said that each character has an ASCII value assigned to it, assigned to that particular character. So with respect to the ASCII value, it is a numerical value or it is an integer value. So when we assign a signed or unsigned symbol to the char type, actually what we are doing is we are assigning that signing or signed or unsigned to the integer that is holding that particular character in terms of ASCII value. Then the different data types, the qualifiers. That is, the qualifiers are, as we said, it is signed, unsigned, long and short. So the char can be char or unsigned char. So a char will be having a bit width of 8 bits. 8 bits means 1 byte, or that is 1 byte will be reserved for a variable of type character. And the range is -128 to 127. That is actually what you say, the ASCII values. ASCII values -128 to 127 can be taken for this char. Unsigned char, if it is unsigned char, the value will be from 0 to 255. It is again of 8 bit. The signed char, if it is a signed char, again it is 8. It is like a char itself. If we see this char as well as unsigned char, both are the same. Then for an integer, it is 2 bytes are stored, or 16 bits. 16 bits means 2 bytes. That is 8 bits is a byte. So 2 bits are, 2 bytes are stored for an integer type. So the value that can be stored for in an integer is minus 32,768 to 32,767. Any value in between these ranges, in between this range, can be stored in integer. But the problem is if the value exceeds this limit, that is, if it is 32,768, then it cannot be stored in a variable of type integer. So that is it. Then unsigned integer. In that case, you can go for unsigned integer if the value doesn't go to the negative symbol. So here it can be, again it is bit width is only 16, but the range is from 0 to 65,535. So that is the difference between int and unsigned int. So if it is again signed integer is again same as, see it is same as these two, this one as well as this one, same as integer. Signed int as well as short int, both are same as int. Unsigned short int, again unsigned short int is same as unsigned int. So these are the different types of data types along with the qualifiers. So then there is unsigned short int is there, signed short int is there, long int is there. So in the case of long int, the bit width is 32, that is 4 bytes are stored. So the value is very large. The range of values that it can hold, it is very large. So then there is signed long int, unsigned long int, then float. Float also can store up to 32 bits. That is 3.4 e to the power minus 38 to 3 to the 0.4 e to the power plus 38. This much value a floating point variable can store. That is, in most of the cases, that is good enough. That is enough for our working purpose. A floating point, the maximum of a floating point. The integer can be a maximum of long integer, or it can be an unsigned long integer. No problem. That much value is enough for our normal calculations. And if we want more range, then you can go for a long float or a double. Long float is equivalent to double C, 1.7 e to the power minus 308 to 1.7 e to the power 308. So that is too large a number. It has 64 bits, that is 8 bytes is the memory size of long float. Then for long double, it is again more than that. That is holds almost 10 bytes of memory. That is 80 bits. That is 10 bytes of memory. The value that it can hold is too large. That is 3.4 e to the power minus 4938 to 1.1 e to the power 4932. So that is too large. That is that type of value we normally doesn't have encounter in our calculations. So then the data types and the corresponding format specifiers, the formats control strings that is used for each type of data types. If you go for the %C format specifier, it is the character. So it can be used to support display the character as well as unsigned character. Then %D, that is a signed integer. it is short, unsigned, short, int, long, etc. That these type of integer values can be displayed using this percentage %d, and using percentage %f, floating point values can be displayed. And percentage %s is normally used for string values. String values or a string strings are actually we take it as an array of characters. So that is why it is a character star is given. This star means actually it is a pointer that we will see later. So that is a character pointer, the percentages. Then for floating point, it is a f. Then for double, it is a LF, percentage LF, that is floating point. And if you want to denote the numbers in scientific notation, that is something like 1.7 to the power into 10 raised to 5. So it's something like this, and this thing will be displayed in C as 1.7 E5. 1.7 E5. That means 1.7 into 10 raised to 5. This type of notation can be represented or displayed using this percentage E symbol. These are the format specifiers that we will be commonly using, that is up to percentage E mostly. Then HI, percentage HI is there, percentage HU is there, percentage I, percentage LD, or percentage LI, percentage LF, capital LF, not small LF. Both will be having difference. This is for normal double, and this one is for long double, percentage LF. Then percentage LU, percentage LLI, DI, or percentage LLD. These are for signed integers, that is long type. So these type of are available in C, and when you are doing some very large programs, or when you are fiddling with the large data, in that case you can use it. Otherwise, in our small programs, we don't have to use all these things. Then for each data type, what are the format specifiers? In the previous slide, it was given for each format specifier, which are the different data types. So here it is for each data type. For integer, either you can use percentage %d or percentage %i. The size in bytes is usually 2. Usually for at least 2 is available. At least 2 bytes is. So depending on the system, or depending on the compiler, the size for integer varies. That is, in the older versions, they were using only 2 bytes. In the newer version, it is 4 bytes is being stored. In any way, for character, it is only 1 byte. It is the format specifier is percentage. See, we have seen all these things again, all these things before. So I think I can skip this particular slide, but when you study, just to go through these things also. And variable declaration, then how we will declare a particular variable, that is this particular name, this particular identifier is given to the given as a variable. How we will declare it, that is how this is done. So variable declaration or definition tells the compiler where and how much storage to create for the variable. So we have seen how much is the storage space, or how much is the memory associated with each data type. So when we define a particular variable as of a type, say integer, in that case 4 bytes are stored for storing the values that will be assigned to that particular variable. So that is the condition. So a variable definition specifies a data type and contains a list of one or more variables of that type. So we will see how we have already seen how variables are defined, like integer 1. So this is a variable declaration. This is a variable declaration. So again, the second was integer 2. So this is another one. Combining these together, we can write it like this: integer 1, integer 2. So this way also, then end with a semicolon. So this way, this way of defining or declaring variables is also possible. That is, if multiple variables are of the same type, then you can use separate them with a comma and declare it in the same line. So the general form of a variable declaration is type. This is the data type. Type means the data type. Here it is int. Here it is int. Then the variable list, the list of variables, whether it can be only one like this, or it can be a list of different variables like this. So both is possible. So type must be a valid C data type, and the variable list consists of one or more identifier names separated by commas. So that is how variables are declared. Some of the examples of variable declarations. This is the data type int I comma j comma k. So these are the variable names int I, int j, int k. So that is what it means. Instead of writing it in 3 different lines, you can write it in the same line itself int I comma j comma k. Then the next one is char, char, c ch. So 2 character variables are defined here or declared here. Char is char is the variable, I mean the variable type, the data type. Then c and ch are the variable names also given to that type of that variables. Then float f as well as salary, two different variables. Then double d. So that is another variable. So this is how the variables are declared. Next is variable initialization. The variable initialization, the variables can be initialized during their declaration itself. That is, the initial values, the values for the variables can be given during the initial declaration itself. That is the initial value that is given. The initialization means giving some initial value. Some value is assigned to that particular variable when it is being initialized, when it is being declared. So that is the initialization. So in our program, in our previous program that we explained, we were inputting the values by the user. No initialization was being done. So in initialization, what happens is an equal sign is also there, which is followed by a constant expression as follows. Something like this. This is the data type. This is the variable name. In this case, no variable list can be given. Only a particular variable can be given. Then the value is assigned. Then using comma, you can give another variable name as well as another value. That is also possible. Like suppose we are float a equal to 1.5. Then with a comma, you can give a b equal to 2.7. Then without initialization, c and d. Like this is also possible. So in this case, all the 4 variables a, b, c, and d are declared as floating point variables. With the a initialized with a value 1.5, b initialized with a value 2.7, c and d are not initialized. This type of initialization, suppose like int a comma b equal to 5 is given, and we this means only b is initialized. In this case, only b is initialized and a is not initialized. If you want to initialize a also as 5, then in that case you have to give it like this: int a equal to 5 and then comma b equal to 5. Now a is assigned initialized with a value 5 as well as b is initialized with a value 5. So this is how the variable initialization is being done. So some of the variable initialization examples are given here. Char flag a into d 3, f equal to 5, short int num equal to 123, float value 483.45, double root 0.23106 e to the power minus 5. So this is how the variable initialization is being done. So now let's see how these things, the format specifier, etc., is working in our program. In a program, how this will be, how we can see it. So this is a program which represents for different types of data types, variables, different data variables. So we start with include stdio.h, then in the main void, here the variable declarations are done. So the variable declarations, it is a char flag a, here it is char flag a, then int d equal to 3, d is initialized with 3 and f is initialized with 5. Here flag is initialized with a character a. Then short integer, num is short integer, and num is defined as short integer 1, 2, 3. Then a floating point value, a floating point, it is value 25.45. Then double root, root is of type double. It is the value 0.23106 e to the power 3. Then a long double, LDBL, sorry, a long double value, LDBL is defined. And it is assigned with a value 0.5 e to the power 308. 0.5 into 10 raised to 308, that is the value. So now let's see how each one will be displayed in using different format strings. Like we have given different types of format strings here. The first line, it is character, CHIR with the %C symbol is displayed, that is %C. Flag is displayed with the %C. This percentage, this within this single quotes, there is a percentage given. This is given actually. Here actually there are two format specifiers are there. One is %C here, this line, this %C, as well as the second %C. Here is also another %C. So this particular %C will display this percentage symbol there, and this %C will display the value that is assigned to this flag. So let us run it and then see it. Compiled it, run it. See, char with the %C a. So this is the line, char with the %C. So this %C will not be directly printed in case of C programming. In the case of whenever it sees a character percentage in double quotes, the C takes it as a format specifier. So the whatever character is after the percentage, then it will be taken as a format specifier. So in this case, %C is given, so it is a format specifier. Then again another C is given. So this format specifier will occupy, or the first character, the first parameter after this particular statement will occupy the space of this particular %C. See here, character with the %C. This %C is replaced with this percentage symbol. Then C, this C is this one, this C. That is %C. Again, here is another format specifier, %C. That is this flag. Flag is taken as value A. So it is represented here. Then two new line characters are given here. Two new line character in order to separate the output. So see, the output is separated with one more additional line. Because the first new line character, it will take the carriage, the cursor to this position only, here only, and the second new line character, that will take it to the next line. So that is why there are two different lines there. So then the next one, printf int with the %C d %dn. So this %C will print this % symbol. C, int with the %d. So this percentage is coming from this %C. This %C is replaced with this % symbol. Then this %d is replaced with this d, the value of d. The value of d is 3. So the value of d is 3. So %d 3. Then the next line, printf into with the percentage I, into with the percentage I, again 3. So I am then trying to print an integer with the percentage f, that is the floating point. The percentage f is for floating points specifier. So into with the percentage f, that gives 0.000. So actually it should have been 3, but the conversion, the integer to floating point conversion is not taking place. So it is only 0.0000. So then up to this we have discussed. Then some short integer values. We have defined the num as short integer. So some short integer values, we again print those values with percentage d, percentage I, and percentage f. So the short integer with the percentage d, 1, 2, 3. That is, the short integer was 1, 2, 3. So it is percentage, percentage d. When short integer is printed with the percentage d, it is 1, 2, 3. Short integer is displayed with the percentage I, it is again 1, 2, 3. But when it is displayed with the percentage f, it doesn't give any value. That is the problem. That is, it is 0.0000. So the conversion is not happening. Then float. We have a float value, that is float, the variable name is value, that is 25.45. So when we are printing it, again we are trying it with the percentage d and percentage I, percentage d and percentage I. Both gives some junk characters. The some value is printed, but it is not related to 25.45. So what when we are using it with percentage f, it is printed 25.45. Some some 1 is given. It is because of the truncation error. It is because of the truncation error where last a 1 is also coming. Actually, it is 25.45. So it is percentage f. So we are using percentage f. Then finally, a float is printed. Actually, it was not float, I think. It was double root. Actually, I made a mistake. This is double. This should be double with the different format specifiers. Okay, we converted everything to double. Then again we can run it, compile it, then run it. Yeah. Okay. So double with percentage f. Double with the percentage f give you the 0.000231. That is, here the value of root was 0.23106 e to the power minus 3. That is 0.231 into 10 raised to minus 3. So that is equivalent to 0.000231. Then double with the percentage LF. Percentage LF also gives you the same value, that is 0.000231. Then we tried it with the E, that is double with the percentage E. Double with the percentage E will give you the scientific notation, that is 2.3106 into 10 to the power minus 4 or e to the power 0.004. So that is it. So not 0. That is 004 minus 004. So 2.31 E00 minus 004. That is again equivalent to 0.231 into 10 raised to minus 3. So that is how the format specifiers are being used, and that is the problem with the format specifier also. If you are not using the correct format specifier for the given data type, you may not be getting the right answer, or the display you may not be getting the correct output. And that's it for today's class. Any doubts?